With increasing concerns regarding climate change and our fossil fuel sources dwindling, it's already agreed upon by experts that more widespread implementation of renewable energy is mandatory for our future. And really, the age of renewable energy is only a question of time. However, what tends to be swept under the rug are issues regarding energy storage. For example, picture a typical wind turbine farm. We harvest energy when the wind is blowing, but what do we do when there isn't enough wind? What do we do when the wind is generating more energy than what we need right now? Can we save this extra energy for later, or does it just go to waste? It's actually these issues regarding unreliability and a lack of energy storage that largely holds renewables back at present. And this is where my research comes in. Right now, I'm looking at flow batteries as a means of both large-scale energy storage and supply. In a flow battery, a fluid electrolyte is pumped to a solid electrode. Chemical reactions between the electrolyte and electrode are how the flow battery stores and generates energy depending on what's needed at the time. We can couple renewable energy supply with flow battery energy storage, like I've shown in the picture here, such that extra energy generated by the renewable can be stored in the flow battery by charging it, and when the renewable can't meet current customer demands, we can close this deficit by discharging the flow battery. Right now in the lab, I'm assessing the viability of halogens and halides for these flow battery electrolytes. Halogens are the elements that occupy the second to last column of the periodic table, such as bromine and iodine, and halides are their corresponding ions, such as bromide, iodide, and chloride. What makes these halogen species so promising and interesting for this application are the so-called polyhalogen complexes that they can form in the electrolyte. Depending on the electrolyte composition, you can have the formation of these polyhalogens between a halogen and a halide of either the same or a different element, many of which have shown very promising energy storage capabilities. For this reason, the main part of my research has been fine-tuning our electrolyte composition, which involves selecting the best combination of halogen, halide, and solvent, like I've depicted in the top left of the slide here. The second part of my research has been identifying and screening a variety of different highly active but low-cost carbon materials to act as the electrode in our flow battery, like I've shown in the bottom left of my slide. Basically, the better the electrode, the better the flow battery. By making these systematic adjustments to both the electrolyte and electrode composition, we're able to improve the performance of our flow battery. Through this teamwork effort between the renewable and flow battery, we're able to improve grid stability and improve the viability of renewables for our future. Thank you.